Your smartphone has more computing power than the entire Apollo program. The chip inside it processes billions of operations per second. The AI assistant on it can hold a conversation, write code, and analyze medical images. And yet, trace it back far enough, and you arrive at a switch. That's it, an on-off switch. One tiny transistor that either lets electricity through or doesn't. That's the primitive. That's the atom of modern computing. This idea that every technology, no matter how sophisticated, can be traced back to a small set of foundational building blocks is one of the most powerful frameworks for understanding where tech came from, where it's going, and why certain breakthroughs feel like they come out of nowhere. Today, we're tracing the story of tech primitives. From the lever to the transistor to the transformer architecture powering modern AI. And by the end, you'll see that every tech revolution in history follows the exact same pattern. Let's get into it. The word primitive usually means simple, basic, early. And in the context of technology, it has a specific meaning. A primitive is the smallest functional unit that can't be broken down further without losing the thing that makes it work. Think about the lever. The ancient lever, a stick and a fulcrum, is a primitive. It doesn't do much on its own. But combine levers in the right way, and you get pulleys. Add pulleys to a wheel and axle, and you get a crane. Add a crank and a gear system, and you have a mill. Add water pressure to a mill, and you have the first industrial machinery. None of those things is magic. Every one of them is just primitives, stacked. The same is true for fire. Fire enabled cooking, which changed human biology. Fire enabled metallurgy, which created tools, which enabled agriculture, which enabled cities. Fire is a primitive. The city is a consequence. What's interesting about primitive tech is that it's often the stuff that looks the least impressive at first. Nobody in ancient Rome was writing breathless scrolls about the lever. It was just a tool, obvious, everywhere, boring. But the lever was doing the invisible work of making every more complex thing possible. That's the first pattern to recognize. Primitives feel mundane until you see what they enable. Fast forward to 1947, Bell Labs. 3 physicists, Shockley, Bardeen, and Brattain, are working with a sliver of germanium crystal and a couple of wire contacts. What they build that December is, by any serious measure, the most consequential technology ever invented. The transistor. A transistor is a switch. That's the whole thing. It either lets an electrical current pass through, or it doesn't. On or off. 1 or 0. On its own, it can't do anything you'd recognize as useful. But here's what happens when you combine transistors. You get logic gates. A logic gate can perform a basic operation, and or not. Combine logic gates, and you get circuits that can add numbers. Combine those, and you get a processor. Shrink the transistor to nanoscale, cram billions of them onto a chip, and you have the CPU inside every laptop on the planet. The entire digital revolution, every computer, every smartphone, every server farm running the internet is transistors. Billions and billions of on-off switches arranged so cleverly that they can render video, train machine learning models, and autocomplete your text messages. This is the second pattern. Primitives don't need to be powerful. They need to be combinable. The transistor is binary, one thing, 2 states. What makes it matter is that binary is infinitely combinable, and combinability is what actually moves civilization forward. Around the same time, a mathematician named Claude Shannon published a paper proving something that changed everything. Any information, any message, image, sound, or piece of data could be represented as a sequence of ones and zeros. That paper created the mathematical foundation for the digital world. Together, the transistor and information theory are the two primitives that everything running on electricity traces back to today. Every era's advanced technology eventually becomes the next era's primitive. The telegraph was a breakthrough in 1844. By 1876, the telephone used the same wires and made the telegraph look like a toy. By the 1920s, the telephone network was the primitive that radio broadcasting was built on top of. By the 1960s, those same communication networks were the substrate that ARPANET, the precursor to the internet, was laid over. Each of these innovations didn't replace what came before. It abstracted it, made it invisible, made it a foundation. This is one of the most underappreciated dynamics in tech history. The internet didn't destroy the telephone, it swallowed it. The telephone became a primitive, a dumb pipe that the internet ran through and eventually ran on top of. And now the internet itself is a primitive. Google Maps used the internet as a primitive to build navigation. Uber used GPS and maps as primitives to build rideshare. Spotify used broadband internet as a primitive to build music streaming. None of these companies built infrastructure from scratch. They built on top of existing primitives and created something new. The cloud is now a primitive. Every startup in the world rents computing power from Amazon or Google or Microsoft instead of building their own data centers. That abstraction, treating an entire server farm as a simple building block, created a whole generation of software companies that could go from idea to global product in months instead of decades. The pattern. Whatever the most powerful, expensive, and complicated technology of one era is, it becomes the free infrastructure of the next. Which brings us to today. We are in the primitive stage of artificial intelligence. And I want to be specific about what that means, because it matters. Right now, the fundamental building blocks of AI are being identified, refined, and standardized. The transformer architecture, the design pattern underneath GPT, Claude, Gemini, and most other large language models, was published in a 2017 paper called "Attention is All You Need." That paper is the transistor moment for AI. The attention mechanism inside transformers is a primitive. It's a mathematical operation that lets a model weigh the relevance of different pieces of information relative to each other. It sounds narrow. It is narrow. And it enables everything that modern AI can do. Reinforcement learning from human feedback. The technique that makes AI models align with what humans actually want is another primitive. Embeddings, the way AI converts words and images into numbers it can process, are a primitive. These things are genuinely new right now. The papers are recent, the architectures are still being refined. But in 20 years, they'll be the lever and the fulcrum. The invisible infrastructure that nobody talks about because it's just assumed to be there. The signal that a technology has made this transition. It stops being interesting. When something becomes a utility, it has completed its move from innovation to primitive. Electricity is a primitive. Nobody tweets about electricity being remarkable. TCP/IP, the protocol that runs the internet, is a primitive. When was the last time someone got excited about TCP/IP at dinner? In 20 years, transformer models will feel like TCP/IP feels today. The substrate. The thing you don't see because everything is built on top of it. So why does any of this matter? Because understanding the primitive layer of a technology is how you identify what's actually valuable. and what's just noise. Every time a new primitive gets established, there's a window, usually a few years, where the people who understand that primitive and build on top of it create enormous value. Google understood that the web was a primitive and that the real value was in indexing it. Amazon understood that e-commerce infrastructure was a primitive and that the real value was in owning the pipes, which became AWS. Netflix understood that broadband internet was a primitive and that the real value was in content delivered over it. The companies that built on those primitives became the largest in the world. The companies that tried to own the primitives themselves largely lost. The same competition is playing out right now in AI. Who owns the primitive? Who builds on top of it? And what does the next layer look like? You don't have to have the answer, but you do have to understand the question. And the question is always the same in every era of tech. What's the new primitive, and what can be built on top of it? From fire, to the lever, to the transistor, to the transformer. The story of technology is really the story of primitives stacking on top of each other. Each generation inherits the infrastructure of the last, abstracts it away, and builds something that would have looked impossible to the generation before. We're living in one of those moments right now. The primitives are being laid down, the infrastructure is being poured. And in a decade, what feels like science fiction today will be the invisible foundation that something we can't yet picture is built on. That's the thing about primitive tech. It's never really primitive, it's just early. If this video changed how you think about where technology comes from, drop a comment and let me know what you think today's most important tech primitive is. I read every single one. And if you want more videos like this, the history, the mechanics, and the big ideas behind the technology shaping our world, hit subscribe and the notification bell. We put out new content every week, and I'd love for you to be part of it. I'll see you in the next one.